Find the third derivative, f triple prime of x, for the function f of x equals secant x, then evaluate f triple prime of pi over 4. So our function here starts out as a secant x. Our first derivative, f prime of x, will therefore be secant x tangent x, and then times the derivative of the inside to complete the chain will be at 1, since the inside's an x. Our second derivative will therefore need to make use of a product rule. We now have a product of two trig functions. The derivative of the first, derivative of secant, is secant tangent times the 1 for the chain rule, times the second left alone, plus the first left alone, times the derivative of the second. The derivative of tangent is secant squared of x, and then times the 1 to complete the chain rule. For our second derivative, we can combine like terms together. So we have, in the first term, a secant x times a tangent times another tangent. We can write that as tangent squared, which I'm actually going to write as tangent and then quantity squared, since we do actually have to take one more derivative here. And in the second term, we have secant times a secant squared. It's 3 secants altogether. For the same reason, I'm going to write that as secant x and then cubed, so that we can see the order in which to take the derivative. And now we can find our third derivative, f triple prime of x. The first term is a product rule, a secant times a tangent x squared. Derivative of the first, derivative secant, secant tangent, times the second left alone, tangent of x squared, plus the first left alone, secant x, times the derivative of the second. Now that's a power rule overall, so we're going to bring the power down. We're going to leave the inside alone, and then we're going to multiply by the derivative of the inside. Derivative of tangent is secant squared of x, and then we multiply by the derivative of the inside of that. Well, that's just an x, and derivative of x is a 1 to complete the double chain rule there. So that's the product rule for the first term. The second term is a power rule. Bring down the power. Leave the inside alone, subtract 1 from the power, multiply by the derivative of the inside. The derivative of secant is secant times tangent. And then we have to multiply by the derivative of the inside of that. The derivative of x is a 1 to complete the double chain rule. There's our third derivative. Let's simplify, combine like terms before we attempt to evaluate this. So the third derivative will be, our first term, we have a secant times a tangent squared, which will be a tangent cubed. Our second term, we have a 2. Let's move that to the front. We have a secant and a secant squared. That's a secant cubed. And a tangent. And then our third term, we have a 3, and we have a secant squared times a secant, which is a secant cubed times a tangent. And it looks like we can combine together our second and third terms here, since they're both of the same form, secant cubed tangent. So our third derivative can simplify down to secant x tangent cubed x plus 5 secant cubed x times tangent x. Now it is possible to factor this. There is a common factor of secant in both terms, so we'll be able to factor that out. We have a secant to the first, we have a secant cubed. We can factor out the lower power. when you factor, you're subtracting exponents. We're taking out a secant, so we will be left with just a tangent cubed x for the first term. And for the second term, we will take out one of the secants, so we will have a secant squared. And everything else stays the same. We can also factor a tangent out of here. And so I'll have a secant x times, we have tangent to a power of 3, tangent to a power of 1. We can factor out the lower of the two powers. It'll be a power of 1. If we factor out a tangent, we will have one fewer, so there will be 2 left in the first term. And we will take out the only tangent in the second term. And there's the factored version of the third derivative. The next thing we want to do here is evaluate f triple prime of pi over 4. Plugging pi over 4 in for each of the x's. Secant of pi over 4, tangent of pi over 4, times the tangent squared means to take the tangent of pi over 4 and then square the result, and 5 times, and likewise secant squared means to take the secant of pi over 4 and then square the result. Now, secant of pi over 4 is 1 over the cosine of pi over 4. The cosine of pi over 4 is root 2 over 2. And it will be 1 over that. The tangent of pi over 4 is the sine of pi over 4, root 2 over 2, over the cosine of pi over 4, also root 2 over 2. Of course, those cancel down, and the tangent of pi over 4 is going to be a 1. Likewise in here, the tangent of pi over 4 is root 2 over 2 over root 2 over 2. And then quantity squared, those cancel down to be a 1. And then we have plus 5 times the secant of pi over 4, which is 1 over the cosine of pi over 4, and then quantity squared. So our first term, 1 over root 2 over 2, we can reciprocate that, and that'll just be 2 over root 2. Second term came out to a 1 for the tangent of pi over 4. We have this times 1 squared plus a 5 times 1 over root 2 over 2. Reciprocate that. That's 2 over root 2, and then squared. So 2 over root 2 times 1 at the beginning will be 2 over root 2. And then inside we have a 1 squared, which is a 1, plus a 5 times 2 squared, which is a 4, and root 2 squared, which is a 2. Root 2 times root 2 will give us a 2. That 4 over root 2 can reduce down to be a 2. So we have 2 over root 2 times 1 plus 10, or 11. So 2 over root 2 times 11, which gives us, multiplying the numerators and multiplying the denominators, 2 times 11 is 22, and then root 2 times the denominator of 1 under the 11, root 2. So 22 over root 2. Now we will want to rationalize this because it will simplify when you do rationalize it. So we will multiply by root 2 over root 2. And this is going to give us 22 root 2 over root 2 times root 2, which is 2. Because the 22 can be divided by the 2 and become 11. So overall we're going to end up with 11 root 2.